Hi and welcome to this video in which I continue my Linux Privilege Escalation series. In this episode we will talk about the exploitation of local services. Sometimes the way to privilege escalation, the way to elevate your privileges is by exploiting the local services that are running on the server. Let's say you got access to a reverse shell. In that server there could be local services which could be vulnerable. So the question is, how do we get access to those local services? So in this video, I will talk about what are local services, and then I will show two practical exploitation examples where we will use two different port forwarding techniques to get access to the local services. In the first one is the local port forwarding, in the second one is the remote port forwarding. And in those examples, we'll analyze some Python code and we have a Docker to play with. So that's the idea. I hope the video is enjoyable. If it is, leave some feedback. Let me know what you think. Share this video with like-minded people to help me grow. And that's it. Enjoy the video. Let's start by describing a little bit what are local services. Now, the idea is that sometimes services are configured to only listen in local network interfaces. Now, a service is any process that listens to a TCP or UDP endpoints, we could say. So typically, the most common services are those that listen on the network protocols, such as TCP and UDP. However, to specify a service, you need an IP and you need a port number. So this is the way to specify a TCP UDP based services. Now, depending on the IP that is chosen, you could expose your service to either a public or private network interface. For example, every machine has the network interface 127.0.0.1. If I expose a service on the IP 127.0.0.1 with port, for example, 1337, now this service is exposed only locally. It means that only processes that are running on my machine can access this particular port. This is also known as the local host interface. So when you expose a server to the local host interface, that is only a local running service. Now, in these cases, we are not able to interact with these services from the internet, which means as an attacker, we can only interact with publicly exposed services, which typically are, for example, HTTP. For example, in port 80, this is the port for HTTP. This is the TCP/80 or TCP/443. This is typically the services for HTTPS, which is HTTP on top of a TLS session, which protects with respect to cryptography. So the idea is that we can only access publicly exposed services. Now let's say though we have a local service that is actually vulnerable and that can allow us to perform privilege escalation. How can we access those services for exploitation? Well, the idea is that we need a way to do port forwarding, which is a technique to join one endpoint towards another endpoint. It's sort of like we connect things which initially we do not have access to. And a simple way to do port forwarding is by using an SSH connection. So anytime we are able to log into the server with SSH and then we find a local service on the machine, then we can use the techniques that I will show in this video through SSH to do port forwarding, to access the local services and to exploit them in order to obtain privilege escalation. So when you connect to a compromised machine, when you get remote code execution into a server, always make sure to check the network interfaces available, and you can do that with the command, for example, EPA, and also check if there are any open ports or processes which listens on well-known ports or in general in any sort of port. So for example, let's activate one of our local service labs. So let's do this one. So I'm gonna go here into source. So this is the local port forwarding. The first example, here there's a Docker file. It's a simple Docker file to deploy this Python application, and here we are creating a user called Ubuntu with the password ABC123. The app itself the app itself, local port forwarding app, is a simple Python app that exposes a vulnerable endpoint /CMD. As you can see, this vulnerable endpoint takes the CMD input from the user through a JSON and then simply runs the command that was specified in the input. So this is extremely vulnerable by design. It's just to showcase the technique. However, notice that this application is run on the local interface 127.0.0.1 listening on port 7777, so like 4 sevens. So let's start the Docker to see what I mean, because these things can be a bit confusing, but I believe that practice will be able to explain it all. So I've just finished to build a machine with the Docker build no cache /t local service lab 1. And now we can start the image, we can start the Docker. So we have started it and we can connect it with the SSH command. So we can say yes, and the password is abc123. So now we are inside the Docker. So to actually enumerate and make sure that we have this local service, let's run the command IPA. So we do IPA, and here we have, okay, we have two interfaces. One is the ATH0 at if17. This is the Docker interface, that is the interface that the container uses to interact with the Docker system. And then we have the typical loopback interface, which has the name LO, with the internet address 127.0.0.1. Perfect. Then we can check for listening ports with the command netstat_ltpn. So this is gonna check for TCP listening ports. And notice that here we have the typical 22 port that listen on all network interfaces. This 0.0.0.0 means listen on all two network interfaces. It means that it's gonna listen on the 172.17.02 and also on the 127.0.0.1. So both, it just means all network interfaces that I have available. Notice instead that we have another TCP process that actually is listening only on the 127.0.0.1 on port 777. So this is our local process. It is the Flask application that is running on the server, on the container. And we can also check with psaux that we have effectively a Python 3 application, so Python 3 app.py. So this is all very interesting. Now let's say that we are in this particular condition. Let's go into app, we can check the code. So we want to be able to access this application, however, not from within the Docker. Why? Because I can already access the application from within the Docker. I can already do, for example, a curl. Let's say, do I have curl? Okay, here I have curl. Let's say that I have a curl, so I do curl HTTP 127.0.0.1 port 777. I go into the CMD endpoint, which is, we can use get, for example. And here I'm gonna use -d to give the data. I have to give it in JSON form, and then I have to say cmd equal UMI. And then here I believe we're gonna do a post, actually let's do a post request. And it says, okay, method not allowed. If I do a get, it says, did not attempt to load JSON because of the request content. So I'm gonna say I'm gonna add an header, content type, and then here I put the colon application/JSON. Okay, notice that here I'm able to do this command directly in the container. So you could say, okay, technically I've already achieved execution as root because this program, this Python script, is actually running as root. And notice here, I said the command whoami, and he replied with root. And so by performing an HTTP request with curl or with any other tool directly in the container, I'm able to access the endpoint 127.0.0.1 of course. Now the issue, the technique that I want to showcase in this video is, okay, let's say however that I couldn't do it within the container. Let's say maybe that I needed to access it graphically with a browser. I needed somehow to access it from my attacker box, not from the server that was already compromised. If I try to access if I try to do the same command from my attacker box, notice what do I get? I get fail to connect to the server. Why is this the case? This is the case because if I just see my attacker box here, and the Docker image, the Docker container, the running image, here the only thing that is exposed is the port 22. I'm using the port 22 to establish an SSH connection. I mean, actually, this is the listening port. Then I use another one to actually send the data. However, this is the listening port. I use this, but the 777 is just used internally in the Docker. It is not exposed publicly. So as an attacker, I cannot access directly the 7777. And this could be a problem if I had to interact with the service, with the web server, and so on and so forth, with a specific setup. Like, for example, I needed to use my browser, the attacker browser, to access the web application. This is not the case for this trivial example, but just imagine we had this issue. So that's the idea. How do we do that? How can we connect this thing? So the idea is that there are two main ways in which we can access a local service. And this is the local port forwarding and the remote port forwarding. Now, in the local port forwarding, the idea is that with this technique, we redirect traffic from a local port on the client machine to a specified port on a remote server through an SSH connection. So the idea is that with local port forwarding, we take our client, which is the attacker. So the client is the attacker. So client equal attacker. And we say, look, I select the particular endpoint, like the particular port 1337. And then through the SSH connection, I'm able to link this port to the localhost 777 port of the remote Docker. Sort of like I create a tunnel between this port and this one. This means that if I send a package to the 1337 of my client machine, the SSH connection will forward it. This is why it's called port forwarding. Will forward it to the 7777 listening on the Docker. So essentially, that's the big idea. Now, how do I do that? This is the first example, local port forwarding. So this is the code we analyze. This is the way like we can access the machine from within the Docker. However, notice that the application only listens in the local interface. How can we reach that interface from the outside? So the idea is to use SSH, and we want to do a local port forwarding, and we can do this with the option -L, so capital L. So essentially with this we are saying connect the local port of the attacker 1338 to the remote port of the server, to the remote endpoint, not port, endpoint, because there's also an IP address. This is IP and this is port. So connect the local port 1338 of the attacker to the remote endpoint 127.0.0.1.7777. And once we do that, our localhost 1238 will be connected to the localhost 7777. This means that we will be able to access the web server running on the container with this curl. So notice here that here I'm doing this on my attacker box. I'm saying on my attacker box, go into the localhost interface into port 1338. Thanks to the port forwarding done by SSH, this will actually go to the localhost of the remote server into port 7777. So essentially, this is how it works. It's just two simple commands. So we quit the previous connection, we proceed with the local port forwarding, we connect, we put the password, and now notice here we have to specify the 1338. And notice now that I'm able to reach the target, and I'm able, let's do an hostname, I'm able to execute code within the Docker container. Notice the hostname is the same. So how did I do that? I did that because now my attacker box is connected through port forwarding to the remote endpoint that is running on the Docker, even though that remote endpoint is essentially a local endpoint, because I connected it with SSH. So this is the syntax for the local port forwarding. Notice here that I'm not specifying the IP address of the attacker. This is because it is implied that it is 127.0.0.1.1.3.3.8. So I can also make it explicit. So I can do this way essentially, ABC 123, and it's gonna work the same. Notice I get root, and here I get hostname. So the full local port command, if you want, is essentially it has the following structure. In the L option here, we are specifying two particular endpoints in the connection. The first one is the attacker/client endpoint, and the second one is the server endpoint. So we are saying connect the endpoint 127.0.0.1.1.3.3.8 to the server endpoint 127.0.0.1.7.7.7, so that all the packages that go towards this 127.1.3.3.8 from the attacker machine go into the server local host port 7777. So essentially this is the first technique. Now in this case it was pretty trivial to exploit the code because it's not really that interesting, the code itself. But just consider, for example, that you have, for example, a debugger listening on a localhost interface, and you want to access that debugger because it will allow you to perform privilege escalation. So if you have a situation where you find like local services, for example, as follows, you do a netstat and you get, oh look, there is a server listening on port 7777, but it is only in the localhost interface. I want to be able to access it from the outside. No worries, you can just do port forwarding. In this case, it is a local port forwarding because we are forwarding traffic from the attacker machine to the server. So from the attacker to the server, and essentially it's sort of like we are being able to access services which would normally be only available to the localhost, to the local network interfaces of the server. This is done thanks to SSH. SSH acts as a port forwarder because it uses the same connection that we have to the machine to forward the ports. So it's a very powerful feature of SSH. And so this is the first example with local port forwarding, where, as we said, it redirects traffic from a local port on the client machine, which is the 127.0.0.1.1.3.3.8, to a specified port on the remote machine, which was 127.0.0.1.7.7.7. And by doing this, we get access to the local services of the remote host. Notice here that the port we choose for the attacker here, for the attacker machine, is arbitrary. We can specify whatever port we want. There is no constraint. The only constraint is on the server endpoint, because the server is specifically listening on that point on its own interfaces. So for example, if you go back to the previous example and we connect but we use a different port for the attacker, let's say we use 4444, it will still work as long, of course, that we use the right port when we connect to the server. So if we do 1238 like this, it's gonna be like, look, I have no connection, so we have to put 4444. But this one we choose on our own. We can choose arbitrary with all the ports that we have available, so there's really no issue there. And so this covers the first example, which is of local port forwarding. So now we can focus on the second example instead, which has to do with remote port forwarding, which is a similar technique. It's just that it reverses the role of who is the client and who is the server. So it just flips the roles. So I have built a Docker for this once again. All this data will be available in the description, so don't worry, you can just follow along. And here we can start the Docker. So we're gonna start the Docker, and once again we can connect with SSH at the same 1237 port. So we connect, we have the password ABC123, and we get access to the system. Perfect. Now, if we check with netstat, notice that we have no server listening on these particular ports. Okay. The actual code in this example is a little bit different, because now we will not simulate a server listening on a local port, which means that we have no server that we want to reach. Rather, we will simulate a client Now, in this second example of remote port forwarding, we will not have a local server on the remote Docker container. Rather, we will have a client on the Docker container. And this client will connect to a localhost interface on its own interface. So it will connect to the localhost 127.0.0.1.4.4.4.4 interface, and it will essentially it will receive a command from the server, and it will execute the command it receives. So here we connect with the socket, then we say, okay, let's receive 1024 bytes, then we split the data we receive with white space, we check if the first element is CMD, and if it is CMD, we execute the second element and we give back the result to the server that sent us the command in the first place. So, for example, and with in the configuration of the remote machine, we can do a sudo -l to say, look, with no password, you can execute this usrbin python3 app. So we're gonna do this command. We can execute it with sudo. So it says, look, problem during communication, connection refused. Why does it give us this problem? Well, the idea is that the first thing it does, so this is the globals, here are the libraries, this is the main guard, and then we call main, and main tries to connect with the socket. If there are problems in the connection, we just print an error, problem during communication. In particular, here it says connection refused because currently there is no listening services on the remote server. There is no services that is listening on port 4444. So we are not able to exploit this because it just crashes. How can we make it not crash? Well, there could be different ways. The first way is to start our own server in port 4444 directly from the container. So directly from the container here, somehow I start a server in the endpoint listening on 127.0.0.1.4.4.4.4, and also I create a malicious server that sends the command I want. So this is a way we could handle this case. For example, this could be done with netcat, but we do not have netcat in this machine. There could be other ways. However, the way that I want to show is through port forwarding. Now, in particular, this time, we will not forward a client, we will forward a server. That is, like we will use, so with the remote machine, we can execute the script. So the problem is that we cannot create a local service listening on that port. Now, to solve this other problem, notice that this is a different problem, because now we have a client on the remote machine, and we want to give to the client a proper server. We want to forward the server, essentially. So to solve this problem, the idea is to use remote port forwarding, which allows us to connect the Python script TCP client with a remote service that is running on our machine. So while with local port forwarding, we get access to services that are running on like the internet, that are not exposed to the internet, however, with remote port forwarding, we do the opposite, essentially. We expose our server to clients on the internet. So that's the idea. It's just reverse. It's because we are using the client-server model. We are assuming that the client connects to the server. So with local port forwarding, we connect to new servers. With remote port forwarding, we are exposing servers to new potential clients for new connection. So how do we do that? The idea is literally the same. So we say, look, I'm going to expose with remote port forwarding my local port 4444, and I'm going to expose it to the remote port 1338. So the syntax for the remote port forwarding, now in the first section of the command, we actually have the endpoint on the server, and on the second part, we have the endpoint on our client. So the idea is that the first one is always the client, the second one is always the server. So the way we do it essentially is that we connect with SSH, then in our host, we set up a server listening on port 1338, and then we are able to connect it from the machine, from the client TCP running on the container. Because when the client TCP will access its own localhost 4444, thanks to port forwarding, that endpoint will be connected with our localhost 1338, with the 1338 of our localhost machine. So how do we do this? It's pretty simple. First we connect with SSH, so we quit the previous connection, we connect like this, and then we put ABC123. Perfect. At this point, let's check the ports here. Notice that we have here, we have this local service that SSH has just created, 127.0.0.1.4.4.4. So now the client will be able to connect to this port in the localhost, to port 4444. Of course, at this point, on our end, in the 1338 port, no service is actually listening on, so we will still have the same problem. Like, if we just do this, we're still gonna have the same problem. It says port failed, right? So we're gonna have the same problem. However, notice, if I just now start to listen on port 1338, so now I just set up my server. With the remote port forwarding, my server is exposed to more clients, and in particular now I launch the script on the Docker container, and look, I got a connection from the client in the Docker container towards my server. At this point here I can send to the client the command cmd who am I. The client will execute it and it will give me root execution. It will say, look, I am root. I can start up a new session. I can connect back and I say host name, and it's gonna give me the host name of the Docker, which is F03F1555-0F86. So the idea now is that we are not using the clients to connect to more servers. We are exposing our own server here, which is a simple netcat. It's a simple TCP server that is just a dump server that does nothing, just what we tell it to do. And then we are able to connect it, we are able to connect to this server through the TCP client because we had forwarded the ports before. Like we do connection and here we can do whatever we want. So it says, of course, no such file or directory, it has a problem and so on and so forth. So the command for remote port forwarding is /r. Here I have to put, here I can put the full endpoint on the server and after the semicolon here, so it's like, once again, I have 2 endpoints to specify. If I don't put the IP, it's gonna assume it's gonna be the localhost IP, so 127.0.0.1. So this first IP is the endpoint on remote container. The second is endpoint on my host. And I'm gonna connect this particular endpoint to this other particular endpoint. But now the flow of data is inverse with respect to the local port forwarding, because now data flows from this port 444 to the 1338. So before it was from my host to the remote server, now it's from the remote server to my particular host, because actually my host contains a server. So that's essentially the idea. And essentially that's it for the local service exploitation. Just remember these 2 techniques. Ask yourself if you need to access remote servers, then do a local port forwarding, choose an arbitrary port on your machine and select specifically the endpoint where the remote server is listening on. It could be also another interface. Make sure to remember this, it's not always localhost. The remote server could listen on a very specific interface and you're able to access this interface thanks to local port forwarding. This is the case when you want to access a service that is a server that is running on a localhost interface or any other interfaces that are not exposed to the public internet. The case of remote port forwarding is less common. I would say the most common case is local port forwarding. The case for remote port forwarding is less common because the idea now is that we want to simulate a server. We want to trick the client into connect to a server we own. So in this case, we sort of like we're doing the reverse thing. And in this case, we need the remote port forwarding with the /r. So here we select the port that the client tries to connect on. So we are bound on this parameter, and then here we can put an arbitrary port. We can put a server listening on that port on our localhost interface, on any interface that our particular computer can access, and we will connect the client from the remote container into our own server. And this could be used for exploitation. Like for example, you have a client that expects data from a database. You can sort of like trick the client into believing that the data it's receiving is valid, while in reality it is receiving it from your own malicious database. So this could be an idea to use. The most common case, however, especially for privilege escalation, is the local port forwarding case. You get into a server with SSH, you check the local services, you see, look, some service is running, maybe it's vulnerable, maybe I need to access it from my host, and then you do local port forwarding. So I hope the video was enjoyable. If it was so, please leave some feedback. Tell me what you think. Tell me if you ever tried these techniques or how you tried them, if they worked. Share this video with like-minded people to help me grow, and that's it. See you to the next video.